everyone. So this is the TP4. So we know that the differential equation of the boundary layers flows are similar with the analytical equations, right? So although the simplification in specific geometry and flow conditions made, but it is still much difficulty in solving the nonlinear special differential equations. So assuming the steady flow of an incompressible viscous flows over a thin flat plate, so the boundary layers can be formed adjacent to the solid surface as shown in this figure. Okay. So we selected the flat front as a coordinate orange x. Okay, the x-coordinate point to the downstream's direction. So in these conditions, the mainstream's velocity is constant to big U. Okay, and the pressure gradient is 0. So that is this equation, right? So the continuity and boundary layers equations are shown below. This is expression 1 and 2. Okay, so in order to combine the two equations into one equation, so we introduce the stream function, big phi. Okay, so after that, the stream functions satisfies the continuity equation and the boundary layers equations, and it can also express to expressions 3 and 4. Okay, so the equation is parabola partial differential equations and has no any geometry characteristics lenses. So the similarity solutions existed. That's we can assume the form of similarity solutions is here. Okay. So this function, so it's the non-dimensional function. So the boundary layers end of the flat plate is taken to 0.5, and the flow parameters big U and V are considered. So the int will be equals to this one. Okay, so the similarity variables, it's non-dimensional variable, and the function form in x coordinate is expression 6. Okay, so with regarding to the similarity solutions, U is also constant and independent with x when f equals consistent. So the proportionally coefficients of these expressions should include the factor, and the dimension of the string functions find is this one. So if our proportionality coefficient includes this equation, this definition, so the dimension is correct. So the founding similarity solution should be in the form of this expression, right? So we're using the equation 5 and 7 as shown before. So the terms in boundary layers equations can be reduced by this. Okay, so after that, taking the equation above into boundary layers equation 3, we can get this one, expressions 13, and after simplification, the similarity solutions are obtained from this one. Okay, so variables x has been vanished in equation 4, and the existence of similarity solutions has been validated. That's the boundary conditions is transferred by this. Okay, so if the functions f and is determined, the steam function phi and velocity u and v can be obtained, then the flow problem is solved. Okay, so we introducing the stream and the similar variables. The primary special differential equations can be transferred into ordinary differential equations, and the solution of the physical solving is simplified significantly. However, solving the equation 4 to get the equation 15th, to get the analytical solution is still difficult, and its expansion of the power exponents and numerical solutions are adopted generally. So the result of analytical solution is shown in table 1. So let's see the table 1, okay? So this is the result of the analytical solution. Okay, thank you.